I've been an amateur astronomer since I got my very first telescope, almost 15 years ago. And after all that time, I've just now built my very own personal observatory. Tonight, I want to use it to go photograph some galaxies, but there's just one problem. I don't have a telescope that can capture them. Even though other galaxies are incredibly big, they're so far away that they appear quite small in the night sky, making them out of reach for smaller telescopes. My refractor is 2 inches wide and 10 inches long, perfect for the bigger nebulas, but not so good for other galaxies, which are basically the only things up in the night sky right now. We're in the middle of what's called galaxy season, the point in Earth's orbit around the sun where the night side of the planet is facing away from our own Milky Way and out towards other galaxies. And because my telescope isn't big enough to capture them, I've been spending each spring season taking a break from astrophotography. That is, until now. In this video, I'm going to debut a new, bigger telescope from my observatory to try and capture one of the most famous groups of galaxies in the universe. If everything works as planned, it could be the most detailed space photo I've ever taken. And along the way, we'll uncover the millions of years of history hiding in plain sight among these galaxies. Let's go out to the observatory and get started. To support a bigger telescope, I also got a new mount. The mount is the most important piece of your whole setup, because it moves your telescope to match the Earth's rotation, allowing the long exposures needed to take good photos of space. In other words, you could have the best telescope and camera in the world, but without a good mount to support it, it's basically useless. This one can hold 30 pounds of gear, which is plenty for what I need. I think this mount will serve me well in this observatory for many years to come. Only after getting that set up is it time to bring out the new telescope, which I'm super excited about. It's 103 millimeters wide, double that of my smaller telescope, which means it collects a lot more light and a lot more details. That's important because this new scope is 27 inches or 700 millimeters long, almost 3 times the focal length of my smaller scope. Focal length determines how zoomed in you are, which means the photos I take through this scope will be almost 3 times as close up. That's perfect for going after galaxies. Now, just because this telescope is bigger doesn't mean it's any better. There are plenty of good targets for smaller scopes, just not at this time of year. And in the future, I'll be switching between the two, allowing me to capture everything from the small galaxies to the big nebulas and everything in between. Everything's set up, plugged in, and we're ready to go. You can tell that spring has arrived here at the observatory. The grass is getting greener, the creek is flowing stronger, and you can really start to hear the sounds of all the wildlife. It's also warm enough to be comfortable out here for the first time in a while. We have a new moon tonight, which means the skies will be as dark and as pure as possible. Perfect for going after galaxies. The target tonight is one of the most famous groups of galaxies anywhere in the universe. It's called the Leo triplet because it's 3 different spiral galaxies in the constellation Leo, tens of millions of light years away. They're close enough together to all fit in the camera frame at once. When it gets dark tonight, they'll rise to the south-southeast over the hill there and be up all night for me to photograph. I recently went after these galaxies with my smaller telescope. I think this will give you a good preview of what we might be able to capture tonight. Here you can really see that it's just beyond the limits of this telescope. As you zoom into the galaxies, there's not a lot of detail. So I'm excited to see how much I can improve upon that with this bigger telescope from the observatory tonight. It's really getting darker outside now, and I can see some stars starting to come out. So let's go photograph some galaxies. We're looking out the observatory to the south. Right there in the middle, high up in the sky, is the constellation Leo, which is Latin for lion, and it's named after its resemblance to the animal. On the left side there what looks like a right triangle. If you follow that down, that's where you'll find these galaxies. The telescope is controlled by my tablet, so it's time to go into the map and find these galaxies. Now the scope will swing around and point itself at them. I'll be taking as many 1-minute long exposures of the Leo triplet as I can tonight. That's long enough to reveal all the details, but short enough not to overexpose anything. Here comes the first picture. Even in just this single 1-minute long photo, look how much we can already see. Each galaxy has its own unique shape and structure. When photographing space, the more photos you capture, the more exposure time you get, will lead to more details being revealed in the end. Now all I need to do is let the telescope take pictures all night long. As you can see, there were some thin clouds that moved through at the beginning of the night, but then those cleared out and actually turned out to be a great night to test out this new telescope from the new observatory and see just how much detail I can reveal inside of these galaxies. I took almost 4.5 hours of 1-minute long exposures, and after stacking them all together, here's the final result. Let's zoom in on these galaxies. We see this one from a striking perspective, from the side, making it an edge-on galaxy. It has the nickname the Hamburger Galaxy, because that's sort of what it looks like when you view it horizontally. We can't see the spiral arms of this galaxy, but instead the massive lanes of dark brown dust running along it. This dust is the material that pulls together to create new stars and new planets. The yellow and white glow around this galaxy is starlight. We're too far away to make out individual stars, so instead we see the collective glow from billions of them. Let's look at the other two galaxies of the Leo triplet. We see both of them at a different angle. Here's M65, which is over 100,000 light years across. We can see the long, dusty spiral arms twisting around the galaxy, from the bright center all the way out to the edges. Last we have M66, which is the smallest of the three at about 85,000 light years in size. It doesn't have as sharp a structure as M65. There's two thick arms coming out of the core of the galaxy, and it has this fuzzy glow of starlight around it. At first these might look like any other galaxies, but there's actually even more going on here. Did you notice anything strange about them? Let's take another look at the Hamburger Galaxy. The brown lane of dust doesn't run straight through like we typically see in similar galaxies, like the Needle Galaxy for example. In this case, it's tilted, it's distorted. So what could be causing this? The simple answer is, it's the other galaxies. The Leo triplet is bound by gravity, meaning that each galaxy is pulling on one another, stretching and deforming their shapes. The fact that we can already see its effects means that this process has already been going on for likely millions of years. That's why this looks so strange. We can also see the evidence of these galaxies interacting in M66. The other galaxies are stretching it, which is probably why its spiral arms have that thicker, warped shape. The fuzzy glow around the galaxy is from stars being pulled away and out into space. And the spiral arm at the bottom of M66 curves outward, almost like it's pointing to the other galaxies of the Leo triplet. All three of these galaxies, due to the fact that they're so big and so close together, have been pulling on each other for a very long time now, and this is only going to continue. We know that the Leo triplet used to be farther apart, and now they're closer together. As time goes on, they will get even closer and the shapes even more distorted. In fact, it's likely that eventually, all three galaxies of the Leo triplet will merge to form one giant, combined galaxy. So there's quite a lot going on in this picture, and I'm fascinated by the fact that we can look at it and tell that these galaxies have been interacting with each other for millions of years already. Over time, that's what all galaxies tend to do. They pull together. And in fact, in the far future, our own Milky Way galaxy is likely to collide with our neighbor Andromeda. The night sky is filled with mysteries like this, and even after doing astrophotography for over 5 years now, I learn something new each time I go out under the stars. I'm just getting started, and now that the observatory is in full swing, I plan to keep sharing the beauty and wonder of space with you. So follow along to see what else I look at from my observatory. Thank you so much for watching, and I'll see you in the next one.